Hi guys, question 1. Suppose data are normally distributed with the mean of 230 and a standard deviation of 20. Between what two values will approximately 38% of the data fall? This would have been a lot easier if they would have asked 34% of the data, because we know that would have been between 0 and 1 exactly. But I went ahead and I just took it up to 88% because I know 0 is 50%. And I want to go 38 more, so plus 38 gives me 88%. So I looked on the z table and I found 88% was approximately 1.8 was my z-score, right? And I know that 0 is 50, so I don't have to do anything with that. So I'm going to put my 1.18 as my z-score, and remember the formula, your z or your standard score is equal to your observation minus the mean over standard deviation. So I know 1.18, and what I'm looking for is the actual score that's going to be more than 230, right? And that's my observation, x minus let's see, what's the mean is 230 all over 20. Okay, so I need to multiply both sides by 20. And then add 230 to get my x, right? So let me find the calculator. 1.18, 1.18 times 20 plus 230. Okay, so my x value is 253.6. Okay, so 253.6. So between what two values will there be approximately 38%? It's going to be between 50%, which is 230, and 253.6. Suppose data are normally distributed with a mean of 98 and a standard deviation of 5. Between what two values, and notice it says values and not percents, will approximately 95% of the data fall? I know from my notes and my normal curve that 95% of the data will fall between +2 standard deviations and -2 standard deviations, with this being the mean in the middle. So if the mean was 98 and my standard deviation is 5, then 98 plus 5 is going to be 103. And 103 plus 5 is going to be 108. And that's going to be my second standard deviation level at 108. Then I subtract 5. I'm going to get 93. And subtract 5 more. And I'm going to get 88, I hope, right? Because that would be 10 exactly away from 0. So between what two values? It's going to be between 83 and 108. All right, question number 3. The school psychologist will survey 100 teachers to determine which after-school activities to offer next. Describe a method that would provide a random sample of student population. Okay, so you're going to want to hit, there's several things you're just going to need to do. I don't care how you do it, names out of a hat, school computer, random sample, whatever. But you're going to have to get all grades, right? All genders. Okay. All ethnicities. That may or may not be spelled right. I apologize, you guys. So just however, a random sampling of 15 people from all grades should do it, because it'll be a random sampling. So you describe how you do it in the test. I think it is a multiple choice question. So the answer should be there, but let me know if you want to go over this before the test. And let's see, question number 4. A placement exam for entrance into a concurrent enrollment course yields a mean of 75 and a standard deviation of 5. The distribution of the scores is normal. What percent of scores lie between 70 and 85? So we need to figure out the standard score for both 70 and 85. So we'll just set up our equation. Our standard score equals 70. This is going to be a negative standard score, right? Because the mean is 75 divided by 5. And 70 minus negative 5 divided by 5 equals negative 1. I'm doing this on my head. I hope it comes out correctly. The distributions, blah, blah, blah. Oh, 85. So then we have 85 minus 75. That's going to be positive 10. Divide that by 5. You're going to get positive 2. So what percentage of scores lies between negative 1 and positive 2? We should be able to do this just by looking at a normal distribution. We know that between negative 1 and positive 1 is 68%, right? That's 68%. Just in there. And then plus another, this little section right here. I cannot off the top of my head remember exactly how much is in there. So let's take a look. Oh, it's 95 minus 60. Oh yeah, we should have been able to figure that out. It's 95 between plus 2 and minus 2, right? So if we split 95 in 2, so I'm just playing around with the percents here, right? So 95 divided by 2, 4, 47.5. So from 0 to 2 is 47.5 minus 34, that's from 0 to 1. So 47.5 minus 34, 13.5. Oh yeah, you have that written down in your notes. So this is 13.5 plus 68. This is the roundabout way, but whatever makes you happy. And I didn't want to look anything up. So 9, 10, 11, carrier 1, 6, 7, 8. 81.5. So between negative 1 and positive 2 is 81.5%. 81.5%. All right, what is question number 5? Describe the difference between an observational study, a randomized experiment, and a survey study. Provide an example of a situation that would be best suited for each activity. We've done a lot of this in class, and since every single person's answer is going to be different, I'm going to let you take this, but please ask me any questions before the test or come see me before, not before school, but like at lunch or after school before the test if you have questions. Number 6, a researcher needs to estimate the mean of a population using a random sample size of 428. The sample's mean is 66 and the standard deviation is 7. Using the sample standard deviation as the population standard deviation, predict the actual population mean with a 99% confidence interval. And luckily for us, they gave us the equation we need to use. So all you need to know are where do the numbers go. So down here is the formula it wants us to use, and this will be our interval. An interval answer means we're going to have between such and such number to such and such number. This is going to be the lower value number. This is going to be the greater value number. I'm going to undo that because I think I just made it hard for you to see. But X bar, that's going to be the mean we have, which is 66 minus, and we want a Z value of 99%. So that's what we're going to put here on 2.576. 6 times our standard deviation, which is 7, all over the square root of n is how many people were in the sample. And that was 428. So the lower value number is going to be, and I did this in my calculator, so you are going to want to do it in your calculator and see if you get the same answer. I just put those numbers in and I got approximately 65.13. So approximately, because there's a big decimal, 65.13, that's the lower value of my interval. My upper value is going to be the same exact thing, but I'm going to change it to a plus. So I have 66 plus 2.576 times 7 divided by the square root of 428. And that is approximately 66.87. Sorry, I ran out of room here. 66.87. Okay, so when it asks predict the actual population mean with the 99% confidence interval, it means the actual mean is going to be between 65.13 and 66.87. Nice, right? If you want to practice more, I would suggest doing the same thing, but trying to find it maybe with a 90% confidence interval. And so those numbers are going to be larger, and a 99.9% confidence interval, and those numbers are going to be smaller. Okay? Let's see. Next. Question 7. The mean travel time for high school juniors in Wyoming is 55 minutes, but they must live so far away. With a standard deviation of 12 minutes, find the 68% confidence interval. That's easy. 68% confidence interval is just going to be between -1 standard deviations and +1 standard deviation. So if our mean is 55 and I add 12, 67, and I subtract 12, 43. Okay, so you can predict with 68% confidence that somebody's, and that's how you write it, actually. I don't know how the test wants you to write it, but that's how you actually write it. I'm about to write on here. We can predict with 68% confidence that the travel time for high school juniors in Wyoming, blah, 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 is going to be between 43 and 67 minutes. Let's see, 43 and 67 minutes. Yay! Question number 8. A random sample of Denver decaffeinated coffee has a mean of 4.1 milligrams of caffeine per cup with a standard deviation of 1.1 milligrams. What is the probability that a randomly chosen, so what's the area, what's the percent, that a randomly chosen cup of Denver decaffeinated coffee has between 4.5 and 5 milligrams of coffee? So we just need to find 4.5. First of all, let's see if this matches any of our standard deviations. If 4.1 is our mean, that's 0, right? One standard deviation is going to be 5.2 positive, and a negative standard deviation is going to be 3. So no, we are out of luck. 4.5 and 5 is not going to be either one of the standard deviations, so we're going to have to do it by hand, where we find the standard score of 4.5 and 5. Okay, So we have to put it into our z-score. So z equals 4.5 minus 4.1 divided by 1.1. And this one is z equals 5 minus 4.1 divided by 1.1. I'm going to have to get the calculadora here. So 4.5 minus 4.1 divided by 1.1. Okay, 0.3636, so why don't we just call it 0.36 approximately here. Okay, and then this answer is going to be, let's see, second, enter, second, enter. We'll call this 5 instead. Then divided by 1.1, 0.82. Okay, now we just have to look those up on the z-table, 0.36 and 0.82. So let's see, I had it pulled up. 0.30, 1, 2, 3, 4, 5, 6, 6406. So this is 64.06%, and 0.82 is 0, 1, 2, 79.39. So what is the difference? How many numbers are in between 64.06 and 79.39? Let's do it the old-fashioned way. 64.06, 3, 5, 1, 15.33%. Final answer, 15.33% of those coffees are going to fall between 4.5 and 5 milligrams of caffeine. What's next? Question 9, the Student Council wants to know what percent of students at DCIS travel every summer. The following methods of survey have been suggested. Each method is biased in some way. Explain the bias in each method. Randomly choose 10 classes to survey during the last period of the day. Well, all of those people have classes the last period of the day, okay? So that's going to be randomly biased because they may have something different to say because they're in school the last period of the day. Survey every student taking Algebra 2. Okay, every student taking Algebra 2 is going to be well, I know we have a few 9th graders, but technically it's going to be 10th grade and above. So those are all going to be older kids, right? And that reminds me that here, a lot of seniors do not have the last period of the day, so they won't get chosen. Randomly select parents who attend parent conferences to fill out a survey. Well, if your parents are attending parent conferences, they're a little more into it than other people's families. I would think that they would be more likely to travel. You're going to get a higher percent that travel. Survey every 25th student in the lunch line. Well, students in the lunch line are probably going to have I don't know. I'm thinking might have a little less money than people going out for lunch every day, or people going out for lunch have their own jobs or whatever. So people standing in the lunch line might not have as much money to travel, or those are all going to be younger students because most of the older students go out for lunch. There's a ton of different ways to see why that's biased. For the question number 9, suggest an unbiased method. You could put every student's name in a hat, every single student's name in a hat and choose. You could do a random pull from the calculator, just any way that you're going to get, or that every student in the school has a chance to answer that question, right? And last but not least, Aiden, Paul, and Noah each take, actually this is not second to last. Aiden, Paul, and Noah each take a different foreign language exam. I might need to take an English one right now. Aiden took the Italian exam and scored an 84. Paul took the Japanese exam and scored an 89. Noah took the Lakota exam and scored 92. The national means and standard deviations for the test are as follows. Which test had the widest range of scores nationally? Use the statistics provided above to justify your answer. That's going to be here Japanese because their standard deviation is higher, so they're going to have a farther distance from their mean than anybody else, right? They're going to have 8 times 4 one way is going to be 32 one way and 32 the other direction. So it's going to be a lot longer. You're going to add 32 this way, subtract 32 this way. Okay, that's going to be a bigger range of scores than anything else. Who did the best on the test compared to the national norms? You're going to have to find the z-scores to figure that out. So who took Italian? Aiden took Italian and scored an 84. So he had 84 minus the Italian mean, which is 76, divided by 6.3. Okay, you're going to want to find that score. Then you're going to, that's Aiden. Okay, then you're going to want to find Paul. Paul took the Japanese and scored an 89. So he did 89 minus 76. The mean was the same, huh? But this time we're going to divide it by the standard deviation, which was 8. Okay, and then Noah, he scored, what did Noah score? 89 minus, but they had a higher mean. They had an 85. Lots of people did well on that. Divided by the standard deviation, and it's a tighter score. Everybody did really closely together, right? Okay, so the largest number here, their standard scored, is going to be the person who did the best compared to those. Explain, using the statistics provided above, how each student compared to national standard, identify why the student did the best. Okay, so kind of the stuff I talked about, you just need to explain it a little bit and type these numbers into the calculator to get the standard scores. Again, let me know if you have a question about this. Last one, a reporter used 2 sets of data below to calculate the mean price of dress shirts in Denver. He went to 2 stores, Nordstrom's and Kohl's. Identify multiple reasons why this is a biased representation of the typical dress shirt price in Denver. Obviously, the first reason is that Nordstrom is an extremely pricey store, right? They might have $4 signs in Yelp, and Kohl may have $2 signs in Yelp. So of course, if he only uses these 2 scores, it's going to skew it towards the pricier scores, right? Also, along that same line, Nordstrom's might have the newer representations and Kohl might have knockoffs that were done last year. There's a ton of different reasons and we can go over them again in class. I'm curious to see what ones, a lot of times you guys come up with stuff I don't even think about because your lives are just different than mine. So let's talk about this before the test also. I hope that you are studying and you have a happy Halloween, and I will talk to you later.